Hello dear friends, this is Gerard Makumba of VeggieMath. In this video, we are going to look at descriptive data. Now, descriptive data is into categories. We have the grouped data and then the ungrouped data. Now, we are going to start by looking at the components in each of these type of data. So we're going to start with grouped data, which is said to be continuous. Whereas for the case of ungrouped data, this is the data which is raw. Raw data is what we call the discrete data. This is the data which has not been manipulated in any way. Whereas for the case of grouped data, this here is the data which has been put into classes. And we have an example. We are going to start with grouped data. So an example of grouped data is here. The frequency distribution table below shows the plants in the garden measured to the nearest centimeter. We can see that this data here is in classes. The class of 10 to 14, 15 to 19, 20 to 24, 25 to 29, 30 to 34. Now remember, we say that grouped data is supposed to be continuous data. But if you happen to put this data on a straight line, so that we have here our 10, then 14 here, then the next one is 15 to 19, then you have 20 to 24, you have 25 to 29, then you have 30 to 34. Now these are our classes: 10 to 14, 15 to 19, 20 to 24, 25 to 29, 30 to 34. Now when you look at this type of data, it is not continuous as the definition of grouped data. What are we supposed to do to make it continuous? We shall have to establish what we call the class boundaries. So right now what we have, the 10, the 14, 15, these ones and so on up to 34 here, these are now the class limits. Now class boundaries are the ones which come in to make our data continuous. How are they obtained? If this is our data drawn on a straight line here, so the class boundaries are going to come in the middle here. So you have the value in the middle there, value in the middle there, value in the middle there. Then we shall go ahead to extrapolate and get another value the other side here. Now this value is going to be between 34 and 35. There is another value when we extrapolate this side, which is supposed to be there, such that our data is going to become continuous, like this, like that, so there to there. But how do we get that value in the middle? So this is 14 and 15. We need a value in the middle there. We shall just take the average of the two values. That is 14 plus 15 divided by 2. This will be 19 plus 20 divided by 2. This will be 24 plus 25 divided by 2. 29 plus 30 divided by 2. So we shall be looking for those values. So the value here will be 14.5. This is going to be 19.5. This will be 24.5. This will be 29.5. Now we shall make a deduction about this value and this value after coming up with table. And now we need to extract and have the class boundaries. I'm denoting them with C.B. So right at the moment, the first class should range from this ordinate to this ordinate here. But this ordinate has a value of 14.5 and it is the upper. So I have here 14.5. Then the next class should pick on from 14.5 to 19.5. The next one picks on from 19.5 to 24.5. Next one from 24.5 to 29.5. And lastly from 29.5 to a value which we do not know. Now let's look at the behavior of these values with the class limits here. So we subtracted here 0.5 to get this. We subtracted here 0.5 on these values all over them up to here to get the lower class boundaries here. Okay, so what does it mean? It means that even on 10 we are going to subtract there 0.5, we get 9.5. Then when you look at the upper class limit here, we added 0.5, so we are going to add 0.5 on 34 to make 34.5. There we go. So we have come up with the class boundaries for this type of data. Now we observe that this type of data does not have decimal point. So for the case of data with no decimal point, we shall be adding 0.5 on the upper class limit, and then we take away 0.5 from the lower class limit when getting the class boundaries. Now when we look at this data here, this data has one decimal place. So we're going to see how we find the class boundaries when the data has one decimal place. Again, we are going to draw our line, and then we need to put all these class limits on the line. We have 1.0, 1.4, 1.5, 1.9. Again, we see that these are our classes, and we say that if this is grouped data, then it has to be continuous data. But then we see there are gaps. So what we are going to do is to fill these gaps with a boundary. So we call that a class boundary. So how did we get it last time? We just got the average of these two values. So this will be 1.45. This will be 1.95. This here is going to be 2.45. The average here, this will be 2.95. Alright, so we need to also come up with a table for this type of data, which is going to extract the class boundaries, and we make a big conclusion about class boundaries. So now within this table, we are going to extract what we have above here, and we know that now those are going to be our class boundaries. Remember, we said that the class boundaries are the ones which make our data be continuous. So the first class boundaries that we don't know the lower one here, but we shall make a conclusion. So this is to 1.45. Okay, we don't know the lower one. The next class, which is ranging from 1.5 to 1.9, the class boundaries are this here. So we have 1.45 to 1.95, and next one picks up from 1.95 to 2.45. Next one from 2.45 to 2.95. Then the last class has a class boundary which picks up from 2.95 to a certain value which we do not know at this point. But then here we should look at the class limits and then the class boundaries. Then we discover the relationship. Now when you look at this, for example, and this here, 1.5 as the class limit and then 1.45 as the class boundary, it implies that here we subtracted 0.05 from 1.5 to get 1.45, and the same thing applies here. I'm looking at the lower class boundaries and then the lower class limits. That's what they did. They subtracted 0.05. So when you take away 0.05 from 1, we get 0.95. Now when you look at the upper class limits and the upper class boundaries here, we realize that they added 0.05 on the upper class limits to get the upper class boundaries. So we are going to add here 0.05 to get 3.45. Now in summary, when we are required to find the class boundaries, we are going to make use of the tolerance error, which is equal to a half times 10 power negative n, where that n is the number of decimal places. So if the data has 0 decimal places, like for the case of the first one, we shall substitute 0 for n so that we can be able to discover what to add on the upper class limits and what to take away from the lower class limits. So let's see, for n equal to 0, that means the tolerance error here is going to be a half times 10 power 0, okay, which is equal to 0.5 when we simplify here. And this is exactly what we concluded when it came to data with no decimal places. We say that we shall be adding 0.5 on the upper class limits to get the upper class boundaries, and when we take away 0.5 on the lower class limits to get the lower class boundaries. How about if the data has 1 decimal place? N is going to be equal to 1. Alright, so we substitute in to get the total error. The tolerance error will be equal to a half times 10 power negative 1, which when we simplify, this is going to be 0.05, the tolerance error. So if the data has 1 decimal place, for example, this which we have here, we say we shall be taking away 0.05 from the lower class limits to get the lower class boundaries, and then we add 0.05 on the upper class limits to get the upper class boundaries. So in this video, we have been looking at how to obtain the class boundaries. But hey, before we leave, there are other types of class boundaries which we may encounter. Now we say that group tree data is supposed to be continuous data. Alright, so what does it mean to be continuous? When we look at the previous data here, we observe that what ends here is the value which starts there. The value which stops here starts from there. So to create that continuity is what makes our data continuous, right? Now when we look at this data here already, what stops here is what begins for this other class. What stops for this class is what begins for this other class. The value which stops for this class begins for this class. So this means that this directly qualifies to be the class boundary, right? So there is a difference between class boundaries and class limits. Class limits have a gap within. You can see there is a gap here. Whereas for the case of class boundaries, when you put them on a line, they do not have a gap. The same thing happens for this type of data. So you just need to redraw the table here. You have height, and then you should have the frequency. Now this qualifies to be class boundaries directly. This means we shall have 10 to 15, 15 to 20, 20 to 25, 25 to 30, okay, then 30 to 35 here. So the frequencies follow suit. We have other types of class boundaries. So this type of class boundaries, all of this, they mean the same thing. So my dear viewer, you can pause a video and have a look at these types of class boundaries. They are all equivalent to redrawing your table of this type of data. Now this video has been about explaining to you how we can obtain and work with different class boundaries. Now in the next video, we shall be looking at the measures of central tendency, how to find the mean, the median, and the mode. And if you are new at EduMath, consider subscribing and hitting that notification bell so that you can be notified whenever we make an upload. For now, thank you so much and God bless you.